Hi, so this week in my newsletter, I've got configuration control with NixOS and Kairos and a bunch of tools, including one that can make UDP connections more reliable by wrapping them, blxrep, which replicates disks at a low level using BPF, and some more stuff, including oh, what's going on there? Including a bunch of vulnerabilities and Mr. Beast's guide on how to make videos, which I guess I've already broken all of his rules by this stage. Okay, so configuration control with NixOS and Kairos. Recently, a client asked me about configuration control and mentioned Ansible and Puppet and so on. Which are like nothing like NixOS or Kairos, like completely different things. But I've immediately, given the client situation, I immediately thought of NixOS and Kairos. So these are or in Kairos's case, it's like a meta distribution that sits on top of Ubuntu and gives you like a unified declarative configuration. So you can configure the whole operating system from one file in theory. And Nix, again, it's the same thing. You have the Nix programming language, and with that you can configure the entire operating system from that. With the caveat that not every configuration setting for every application has some way to be configured from Nix or Kairos's configuration files. And they're immutable to some extent. I think maybe Kairos is a bit more immutable than NixOS. I'm using NixOS right now and I can change stuff, but not everything. So you can have atomic updates and rollback because you basically have a snapshot of your sort of base system, and updates happen to a new generation, and then you can roll forwards to that generation, and if the update fails then you just stay on your current generation, and you can roll back to a previous generation as well. Um, and I guess, yeah, one thing I haven't included here as well in this bullet points is you can create like an ISO image or a VM image of these with your exact configuration on, as well as being able to like save your config file and reapply it later. Yeah, so configuration control or configuration management, this could include loads of things like infrastructure as code, GitOps, all of that kind of stuff. Yeah, puppets, as I mentioned earlier, and all of these systems will sort of take a Linux device or even like another operating system, and they'll install it and try apply configuration to it, try and keep the configuration up to date to stop configuration drift. And like these systems kind of exist outside of the operating system. They might have an agent which you install onto the operating system, though, to perform configuration updates. But in some cases, the agent is just SSHD, which comes as standard on most Linux boxes. Kairos actually has its own agent, but it does a whole bunch of other stuff as well. So NixOS and Kairos are not like these other things I've mentioned. They're not like Puppet and Ansible and whatever. NixOS is a full Linux distribution based on top of Nix. Kairos is like a meta distribution, so it takes like Ubuntu and then uses container-based technologies to make it immutable. So it uses file system overlays, stuff like that, and that gives like Ubuntu generations, gives it atomic updates and immutability by using basically technologies made for containers. but it doesn't have a container runtime or anything like that. Like running by default, you still, it's not like the system's installed in a container. It uses the kernel and the init system of the underlying operating system, and it doesn't have a container runtime running when you boot. It only has a container runtime running when you want to run a Docker container or you want to start Kubernetes. And actually, Kairos is sort of made with the intention of being like a good way of installing Kubernetes on a bare metal machine, along with the operating system. So everything packaged from the operating system to Kubernetes. In fact, it can be managed from Kubernetes as well. And it's created by Ettore, who also created Local AI, and I've worked quite a bit with Ettore, so yeah, I might be a little bit biased. um, Oops, okay. I've just clicked on this link back. So let's get into this though. Okay, so this is actually a graph of all of the Linux distributions and maybe some other packages as well, some other package repositories. You can see here at the top right we have Nix packages unstable, with like the most fresh packages by far, and also the most packages by far. So let's go back again. Nice LinkedIn. No, why just have like plain HTML when you can have like a JavaScript thing that loads the entire page in like a single page application type way? Where was I? Okay, we've gone too far now. Yeah, so Nix is actually a functional programming language, and it was created to build software and to package software. And there's the Nix package manager based on that, and you can install that on Linux and Mac. It's actually pretty popular on Mac, I think. A lot of people use it to manage their Mac configurations, and install software on Mac. And then, like, I think it's someone's trying to port it to Windows as well. So maybe at some point it'll also be available on Windows, although it's very much Linux and Unix orientated. So yeah, it's the largest and most up-to-date OSS repository in the world, in terms of built software anyway. Of course, GitHub is probably bigger, but yeah, I mean the Google and Apple stores are bigger, but it's actually not actually like sitting within the same order of magnitude. And Nix is definitely catching up to those. Docker Hub, I have no doubt, is a lot bigger, but yeah, I mean, like anyone can just go on Docker Hub and just put a container up there, of the same application. It's not really the same thing. So NixOS is the Linux distribution built with Nix, and everything can be configured inside a single Nix file. Again, like not absolutely everything, but most things can be configured within a single Nix file. And at least for the base system anyway, I think if you want to manage like your home directory or user directory, then there's like a separate Nix-based system for that. But you can, configure almost everything declaratively using this functional programming language. And like you can see the power of that from the number of packages that are available for Nix, despite it not being anywhere close to the most popular Linux desktop, like nowhere near. So yeah, so the power of the Nix package manager, like we can go and do this. Let's go to here. Yeah. So if I type something like Nix shell below, like I don't have below installed on my system. If I just type this in, now I have below. So I can do sudo, but I think it needs, there we go. And I can instantly try out this tool that I discovered, and actually this is one of the tools I'm demonstrating. You can see something's using CPU time. Um, yeah, so and you can do that for a lot of packages, obviously, because it's because it has so many packages built in, and then there's also Nix flakes as well. So I mean, you can put a Nix flake in your GitHub repository, and then go into it and just build the application using the Nix flake. If you have Nix installed in your system. So that's not necessarily a NixOS feature, but it's again like showing the power of Nix. The problem with Nix is the learning curve. I've never encountered a Linux distribution with such a high learning curve. At least not one that I've actually stuck with. If if Nix wasn't so useful, then I wouldn't continue to use it because it has so many problems. Not that a Nix's fault. I mean, it has a lot of software just relies on everything being laid out for Ubuntu basically. And it's usually the worst programs are the ones which just assume they're on Ubuntu. And yeah, and so you get things like Visual Studio downloading like binaries for plugins and stuff, and like Python. There's a lot of Python packages that like just download some pre-compiled binary from God knows where that won't work with Nix. You could even say that's a feature rather than a bug, but yeah, you've got to do a bunch of when you come across software where you really need it to just work, you have to do a bunch of tricks to make it work. And yeah, the learning curve can be because you end up having to like learn about how C programs are linked together and all of this kind of stuff. So there's a very high learning curve. And then you've also got the fact that it's a functional programming language that's quite unlike any other functional programming language I've even seen. So, yeah, it's got a steep learning curve, but despite all of that, it's like growing in popularity every year. More and more packages are coming on, despite the learning curve and the fact that there was some kind of fallout within the Nix community as well. Yeah, I vaguely remember a post from someone saying, I finally wrote my first Nix Flake package and it only took me 2 years. So yeah, I mean the story's quite different with Kairos. Like, I mean, I think if I mean it's aimed at Kubernetes people, and so I mean if you know about Kubernetes and you're on that kind of level as a system admin, Kairos should be easy, I think. If you're not so familiar with like Docker and containers and all of that sort of stuff, then and cloud init and everything like that, then you might actually find there's a bit of a learning curve to Kairos, especially as soon as you want to start changing stuff and configuring stuff. And if you want to create your own Kairos bundle, which allows you to extend the system-wide configuration, then I'm sure there's like the learning curve starts to get a bit steeper. But it does mean you can sort of, if you're stuck with Ubuntu, which a lot of people are, like whether they like it or not, everyone expects Ubuntu. You can put NixOS on top of it and turn it into something like a sensible distribution. And yeah, it might be technically possible to wrap NixOS with Kairos. So they're sort of the two different things, but still like kind of like alternatives to each other, but not really. I don't know if it'd be technically. I mean, both NixOS and Kairos have their own way of booting, and I think maybe wrapping one with the other would interfere with that. But it might be technically possible. Okay, so down to tools, blxrep. Like, I'm just like amazed by like what you can do with eBPF now. I mean, really, if you think about it, you can do almost anything that doesn't require, I guess, writing to kernel memory. I mean, I don't know. Like, I think maybe I heard a while ago that there was some sort of infrared driver written in eBPF. But anyway, just like the amount of stuff you can do is amazing. I think a lot of these tools actually push the boundaries of what maybe you should do, because a lot of these tools, when you dig into them, you find out that what they've done is they've hooked into kernel trace point. Trace points are fine. In theory, they're fine. But what you find is they're hooking into internal kernel objects and probe points. I mean, this is a trace point, so that's better. But you see, you've got like this structure just here, which I, I don't know that structure is guaranteed not to change. I think it's usually okay if fields are added to the structure, but if the fields in the structure are deleted or changed or renamed or something, that's going to break the BPF. And also if sort of the name of a field stays the same but the semantics change, and that's even worse because it could lead to like a silent error. But still, like these yeah, just incredible what's happening with eBPF, and I'm sure that you know the internal interfaces, the interfaces for eBPF into kernel, like the hook points will mature, and eventually you'll end up with hook points that are more or less considered like system calls, or at least for practical purposes anyway. I've got Node-RED. Discovered this while looking at like process automation for I guess for like industrial and agricultural automation. Yeah, this is like quite a nice looking program that basically it's like a visual low code programmer where you have like these building blocks and you can hook together different things. And that's good. Like, obviously I can write code, but quite often you want to like create a program and then hand it off to someone who's less technical. Or you just want to sort of set up a system where people can go in there and just start automating stuff. And yeah, I know that LLMs exist and they can write code, but the good thing about these visual things is like anyone, like even if you don't know much about code, if you just sort of have like a logical mindset, you can look at that and review what it's done. And I mean, LLMs can write visually coded programs as well. You just have to get the right tokens to create the visual program with. Okay, below I just showed that. Yeah, this is like simple utility like top, but like these aren't processes it's tracking C groups, control groups. So in Linux you have a way of grouping processes together and putting limits on these processes, naturally attaching eBPF to these processes and stuff like that. And this tool from Facebook lets you look at sort of the resource usage by C group, and also like the properties of each C group, like what limits have been put on it. As you can see, there's no limits at all on my personal system. Kind of maybe I should really learn how to change that and sort of segregate applications. But yeah, I mean, by default NixOS doesn't come with, or yeah, I suppose by default system D doesn't. I mean, it segregates things to some extent, but I don't see any kind of. Oh, what's going on there? I don't see any like limits on anything. Yeah. So anyway, yeah, that's below. And finally, oh, we've got eBPF use, more eBPF programs. Yeah, these can be used to inspect like what data is being sent to a USB device, I guess. I mean, I don't know whether these work. I just find it interesting that these exist, because I sort of someone's asking about like how to like record USB events. Well, first thing I do now is to go and look and see if there's a eBPF tool to do that. And then maybe after that see if there's like just like an old school kernel debugging or trace point that I can use. But yeah, like I often go to eBPF first, and like even if this doesn't work, I mean it's written using the BCC Python tools, which I don't particularly like, but you can still sort of go in here and look at the eBPF code they've written and use that in your own program. Most of these eBPF programs are really simple, so you can just sort of take the bits you want and start using those. Use it for inspiration. Assuming, of course, that you understand kernel internals. That's the big sticking point there. And then we've got right. So this is a desktop rag tool, which Ettore tells me this is like one of the few ones that actually work and are reliable. So yeah, this basically this takes I don't know however many trillions of documents you've got that are in PDF format or just plain text or whatever. And then it puts all of these into various types of database, including I don't know like a vector store. And apparently this one uses what's it called? Never mind. It uses a bunch of fancy techniques that allow rag to work well, and it has a UI with it as well. And yeah, apparently there's not many of the open source rag implementations and UIs really work that well, and this one, yeah, apparently does. So there it is. Hopefully at some point I get to try it out. Oh yes, like 119 vulnerabilities in LTE and 5G core. And yeah, this is kind of yeah. So I mean, lots of these can be used for denial of service, which it's kind of looked down upon. It seems in like security research, but denial of service, like it's still pretty bad. Like if your whole city's 5G is taken out, or 4G, or whatever, if it's all taken out due to like software denial of services, that's pretty bad situation. I mean, maybe you wouldn't consider it as bad as getting remote execution on the machines, but it's still pretty bad. Um, yeah, and these guys found a lot of bugs in one go, including some that can be used for I think to get like remote code execution. And they've got sort of they've got their description of how they did it as well. So you can learn how they managed to find so many vulnerabilities. And yeah, and then finally, how to succeed in the Mr. Beast production. So this is like a long, rambling essay, or like company handbook, I guess, from Mr. Beast. I've only watched one Mr. Beast episode because I don't know. For me, it's a bit like a tame version of Jackass. Probably more intelligent than Jackass, but I'm just showing my age basically. But this is actually like a great insight into how to succeed in something like YouTube. I'm obviously not following any of this advice. Um, I'm not sure even my lighting at the beginning is good here. But also that's kind of beside the point. This is just like the company handbook and shows that if you want to be number one on YouTube, this is what you're going up against. And there it is. The end.